I'm Rishi. I'm a PhD student in the Acme Lab, advised by Ellen. And for the next 45 minutes or so, I've not really timed this, so we'll see how this goes. I'm going to be talking about some work that we've been doing in the Acme Lab around spatial collaboration and how mobile devices can be used to better connect people no matter where they are. And yeah, so the next few, I'm going to leave this pointer up here because it'll be useful in a bit. But yeah, there's broadly three parts to today's talk. I'm going to be talking about the state of collaboration, remote communication as it is today, and as research has progressed over the last few decades. And then try to point out the reasons why it's great and the places where there are challenges that still need to be addressed. And then going to talk about the idea of the prototype that we've developed over the last year, slightly more than a year or so, and then how it addresses those key challenges, and then talk about what might come next, both for the prototype and in the broader space of remote communication more generally. So yeah, again, remote communication is the starting point. We'll then talk about mobile spatial computing, and then how the idea of cross-reality interactions, which I will talk about, ties all of this together. I think at the moment there's only one person on Zoom.
There's three.
But, so the last 3 years have seen us engage with remote communication a lot more than we probably did before that. I know most of us probably here have family who aren't in Boulder, who aren't local, and we often have video calls, phone calls, people away. And then I think as tired as we might be of Zoom, I think remote communication is probably one of, at least in my life, the most impactful technologies that I interact with on a daily basis. Families back in India, friends all over the world. But the fact that we're able to pull out a phone, hop on a phone call, get on a video call is something that I often take for granted, but try not to. And this is something that really wasn't available 20, 30 years ago, where you would stand in line for a phone call, wait months for a letter to go across. So I think remote communication is really interesting space. That's the colloquium from last year. You can see the speaker. This is me, I think, giving a talk to my university back in India, and that's Ron and Daniel sort of telecommuting into the Atlas Expo last year. So speaking of 30 years ago, when none of us really had access to this kind of technology, there already was a lot of research happening in the idea of what an ideal remote communication system should be. So this is a screen, like a photograph from early work that was taking place at the Palo Alto Research Center in the late 80s, early 90s, where people were really exploring what it meant to be there with somebody. How could we use audio, video communication technologies to actually connect two spaces together and bring distributed teams together? So what's happening here is that they used a bunch of displays, cameras, microphones set up in offices in Palo Alto and in Portland. And they essentially were able to create this connected laboratory where people were able to sort of move cameras around, see each other on large displays, and almost interact as if the display was more just a window to the other space, entire states away. This was great, and then this was way before any of us had access to this technology. But in the last 30 years, things have progressed way beyond this, and there are entirely new forms of spatial interaction today that allow us to be there or other people to be here with us. One example of this is probably stuff that you've seen on YouTube and on the television a lot with the advent of the Vision Pro. This idea that you could put on a headset and see avatars of people as if they were actually in the same room as you. The idea was definitely sort of thrust into the limelight by Apple, but it's something that's been explored both in product and in research for many years now. So this is Spatial, and that's FormaVision, two startups that have for a while explored this idea of how do we use things like augmented and virtual reality, headsets, fancy displays, and make it seem like you're interacting with people in the same space, even if you aren't. From a research point of view, a project that really encapsulates what this vision is something called holoportation that Microsoft worked on in around 2015 or so. This is going to play, and I'm going to talk over this for a while. But what's happening here is that one of these people is actually in this room, and the other person isn't. And so there are these two spaces, two people wearing HoloLens headsets, AR headsets that allow them to see digital content in their space. And there are a bunch of these depth cameras, Kinect depth cameras that capture not just color, but also information about depth. So the the structure of a human body, the surfaces of the room, the objects that are in place. And what's happening here is that the depth cameras, there are about 4 to 8 of them all mounted around the room. They're capturing 3D volumetric information from the space, compressing it, streaming it across the network, and on the other end, somebody who's wearing a HoloLens can actually see that information as if it's in the same space as them. What you see here is like a composite, but then that's the view from the HoloLens up top to the right, and the bottom right is the sort of virtual reconstruction of what's happening over here. But so you notice that there's people, there's space, they're walking around each other, and there's this vase, an object that they're interacting with. I think that brings up the key elements that you would need to think about when looking at remote communication today. There's obviously the self, the representation that you send across and that you see of somebody else. There's the space and the place. And I think I just want to talk about the difference between the two. So there's spatial interaction. So if you've ever played a game online where you're in a shared room, I don't know, Animal Crossing, you can interact with other people in a space, but that space is virtual. That's still geometrically constrained. You have rooms, you have cities that you could walk around. So there's spatial interaction, but it's not a specific place. The place is where you actually existed. So in holoportation, what was happening is the information that was streamed across the network wasn't just viewed in a VR headset. It was actually viewed in place in your environment. I think that's a key difference between spatial interaction and interaction in place. And obviously, in addition to the space, the person, the environment, there are the objects that we interact with. Like oftentimes when we're collaborating, it's around objects. We use tools that anchor discussions. And that's another thing that needs to be considered when creating these systems. I'm now going to show you another example of another 3D telepresence technology that I think encapsulates the challenges that this space has really well. So this is Project Starline by Google. Again, many of you might have seen these videos before. I'm going to talk over the GIF. So what's happening here is you again have a depth camera that's capturing your entire face, that's then compressing multiple streams of information, streaming it across a network, and then re-rendering that on fancy 3D displays that make it seem like you're sitting in front of a window and actually interacting with somebody right in front of you. So you can look at the video online, it's really compelling as a demo, but I think it points to the challenges that exist in this space, the fact that you need to capture 3D information, which is a lot of information. Like so images can be a few megabits per second to stream with video calls. For a high resolution 3D point cloud, which is a common representation for 3D content, you need gigabits per second, which most of us don't really have as bandwidth for most of our internet connections. So again, capturing requires you to have multiple depth cameras that are expensive. Compression is still hard and not a solved problem. You need to stream this over conventional networks, which really aren't geared for this volume of information, and then render it on the other side, either using headsets or specialized 3D displays. So this is the vision of spatial remote communication. There have been efforts to make this more accessible. So Microsoft, for example, has taken its holoportation technology and deployed it for 3D telemedicine. So what's happening over here is that you have doctors in the UK and then these remote clinics in West Africa where you have a patient walking up to this photo booth of sorts with multiple depth cameras that scans them in real time, streams it across to a doctor who can sort of see a 3D scan and potentially diagnose things with much more information than just a video call. So this is great, but again, you notice that 1, 2, 3, potentially more depth cameras, a really tethered system to one place. So not really scalable. It's good that they've tried this out, but then to do this across multiple situations, multiple locations will be much, much harder. So Ericsson is a telecom company that's also been exploring this space. We've been working with Ericsson for the last couple of years on this project, so I just wanted to bring up something that they're working on, which is using cheaper head-worn glasses. So these are the X-Real glasses that are about $1,000 now if you wanted to buy them, where, again, you put them on, you have a depth camera, and you see this holographic sort of representation of the person in front of you, even if they're not there. And they're also dealing with many of the same challenges. You're looking at large volumes of depth data. How do you, like, even with 5G, it's not really enough to send all of that information. So you need to compress it somehow in meaningful ways and then reconstruct it on the other. And the way they've approached this is by breaking down the computational steps along multiple parts of the pipeline. So what you probably wouldn't have realized in that video is that the glass was actually connected to your mobile phone. So your mobile phone acts as the computing unit for the glass, as opposed to a computer being on the headset itself, which is a big problem with what people are talking about with the Apple Vision Pro being really heavy and hot on the head. So what they're doing is you have on one end somebody who's using a PC with a depth camera that captures the 3D version of your face. You stream that across the network. They've developed some nifty compression mechanisms for that. But then on the other end, the person views it using an AR glass tethered to a phone. So again, slightly better than the initial visions of holoportation, but across the board, there still are key challenges that need to be addressed. Capturing requires, even in this case, depth cameras, multiple depth cameras that are expensive, hard to get sometimes, and once you set them up, they're tethered to that physical space. So the holoportation example was compelling, but you could only holoport between two rooms that had those cameras in place. Compressing and streaming is still an unsolved problem. There are no standards for dealing with 3D information, and networks just aren't there yet to deal with the volume of information required. And finally, rendering. All of the examples that I've shown you so far rely on fancy headsets, 3D displays that are getting more and more affordable, but are still kind of out of reach for most of us. I don't own one of these for myself, and I'm willing to bet many people in this room don't either. So what that's resulted in is this divide between remote communication tools that are accessible, like video conferencing that all of us are familiar with and can use, and then the spatial immersive side of things that provide compelling interactions, but are just not there yet. Like many of us just do not have access to this. And so the crux of this presentation from this point on is to talk about how I think that mobile devices, specifically mobile augmented reality, can act as an ideal bridge between interactions that are accessible but not spatial, and interactions that are spatial and immersive but not accessible. And a bit of background, before I got to Atlas, I did work on mobile AR for a range of contexts, specifically in dealing with sort of mathematics instruction for young children, like in late primary to early middle school. And I started this project late 2019, early 2020. So we built an initial prototype. We did a test in Feb 2020, and then things changed. And so it became a lot less about how do we deliver content or deliver 3D instruction to children, but rather how do we use mobile devices to potentially bring them together and give them an experience that they no longer have in a spatial, like at home, compared to a spatial classroom. So this is like a really, really initial prototype where what you see here are these capsules of people. So what's happening is in everyone's own homes, people are using a phone and sort of walking around this map of India. And as you walk around, your movement gets transmitted to everyone else. And so you can kind of see the object and also see your classmates moving around and talk to them. And it's just a capsule, but it's a little bit more spatial than a video call, something that's much more, potentially more engaging than just sitting in and looking at a screen. And then, so we extended this further. This was for education. We looked at today. So this was Social XR Party. Some of you might have seen this demo early 2022, but happening here is a game of Jenga that I seem to have won. But again, so mobile devices, playful interactions, it was all very great. But then in both the previous, this GIF and this one, you can kind of see that it's like, it's a cartoonish avatar that you really don't believe is another person. You can see the movement, but it's not there yet. And so really with this project over the last year and a half, what we've been looking at is how do we maximize the potential of a mobile device? And not only just make a fun experience, but address all of the key elements of remote communication, self, space, place, and objects, but also try to solve the key challenges of capture, compression, streaming, and rendering. So now I'll just dwell in the meat of this thing, the idea. So dual stream is what we ended up calling it. So again, all of us walk around with one of these in our pockets, sometimes more. And whenever we use them, we kind of take for granted the fact that there's this unique combination of display, processing, and sensors on this that are not available to computers, nor are they available to headsets. The fact that on a computer, you don't really have a gyroscope or the ability to sense motion, or cameras that look at the environment in front of you. Headsets, crucially, don't have a camera pointed at your face because they essentially cover up half of your face, and then you really can't share your own expressions to somebody else. Phones kind of can do both, because whenever we use a phone, we always have one camera pointed straight at us. Whether or not it's on, it's pointed at us. And we have one or more cameras pointed at the world around us. And now, more advanced phones, like the more recent iPhones, actually have depth cameras both in the front and in the back. So the idea here was, what if we could use just the phone to capture information about yourself using the front camera, information about your surroundings using the rear camera. Again, when you move around with the phone, with AR, you can track the position of the phone. So combine all of that together, stream it across the network, and then view it on a mobile device, where you could potentially see other people moving around in your space with their real representations, but also look at environments shared in real time. Small note, even though the iPhones have the cameras today, you can't really use them. So it's not really possible today to access the color and the depth streams from the front and the back camera while also doing AR tracking, because Apple just hasn't made the API available to us yet. Nor has Google for that matter. A lot of Android phones do have the ability to record video from the front and the back. Video already allows you to take photographs from the front and the back at the same time, but this API isn't accessible to developers yet. So we had this idea, but we couldn't prototype it just on a phone. So what we ended up doing instead was conjuring something up like this. So this is a standard Android phone, but we've strapped on top of it a depth camera, an Intel RealSense depth camera that costs about $300. And you just connect it to the phone via USB, and it acts as a front-facing camera. So this was just to prototype interactions that are likely to be available in the near future, but we didn't want to wait for that. And so this is us just trying to put something together and work with it. So this was the idea. And we went ahead and we made the thing. And there are a bunch of scenarios that we've tested this in and sort of showcased it. I'm going to walk through a lot of these right now, but I'm going to begin and show you the value of this idea by focusing on just one of these things, the idea of truly remote assistance. Now, consider how previously the holoportation examples, for example, you had to be in that specific room with multiple depth cameras to be able to stream information. And a common use case for this is, when you are able to have spatial remote communication, you could have spatial remote assistance. You could have a technician in the field fixing a mechanical problem on a power line, and you could have an expert in the main office sort of guiding them through spatially. But again, while that vision is great, in practice, it's really hard to do given the hardware involved and the difficulty of setting it up. But with a mobile device, you can kind of go beyond that. And for a moment, imagine this scenario. So Torin, many of you know him. He was a PhD student in our lab. Imagine for a moment that he is out in the middle of nowhere and his car is broken down and he really needs help to figure out what's wrong in the engine. For some reason, he calls me. I'm at home, and I'm supposed to be an expert despite never having driven a car or whatnot. And so he's asking me for help about, okay, what's wrong with the engine? Now, status quo today. If this was a normal video call, Torin would open up his phone, turn on the rear camera, FaceTime me, or just call me over WhatsApp, and I would see something like this on my screen. This is Torin's view, which will become clearer in a little bit. But I would just see this video on my phone, and I would be entirely dependent on what Torin is looking at. So if I was like, can you show me one of the lights on the other end actually? So I'd have to ask him to move there, see the thing, move back. There's often a lot of verbal spatial communication here that can be confusing at times, and there's research about this. But this is what I would currently see. With dual stream, what happens is the 3D information of the car is sort of transported into my living room, and I see a point cloud representation of it in my hall that I can independently walk around. So as Torin looks at the car, what he sees in front of him gets captured in 3D, streamed across the network, and sent into my living room, and that I can actually independently walk around and look. On the flip side, when you have these mobile video calls with other people, you often see the person you're talking to as a really tiny rectangle on the screen in front of you. With dual stream instead, what happens is I become a creepy floating hologram by the roadside that is actually, so again, you'll have to take a second to wrap your head around. So Torin looks at the car, streams that car's information into my living room. So I'm looking at the car and I'm walking around it in my living room, and then the position of me relative to the car gets sent back to Torin along with my face that he can see as if I was actually by the roadside there to help. Similarly, I see Torin in my living room, and I can point at the car that results in a laser pointer that goes into the real world. So it's more than just verbal communication on the video feed. This is spatial communication in each of our spaces where I'm able to talk and point at things and sort of potentially solve the problem together. So there are a lot more scenario examples that I'm going to walk through, but I hope this gives you a sense of the key idea behind DualStream, where we're trying to be able to share representations of ourselves that look like we do and move like we do, but also where we're doing two things at the same time. I am being there with Torin by the roadside to help him, and he is being here in my environment, and we're able to share both information about self, space, and place with each other. So there's a lot happening over here, and I hope that gave you a sense of what this application can do. So before I dive into more examples, I want to talk about some of the key features of what DualStream is capable of. So this is what the interface looks like. Forgive the creepy Torin head, but what I want you to see or take away from that is the fact that that does kind of look 3D. At least I think it does. Like you can kind of tell the facial contours, the flap of the hat, and in an ideal condition, we are with DualStream able to sort of get a sense of 3D information about the face and to some extent the environment. So there's like a very, very minimal interface that allows me to switch between certain features that I'm going to talk about. Now, so up until now, I only spoke about sharing 3D information, but with DualStream, you can also just share the two-dimensional video feed of yourself or of your environment. But when it's placed in space, it adds a lot of value, which will become more clear in the GIFs. But this is just to say that with DualStream, you can capture information in both 2 and 3 dimensions, and also view this information when streamed across in both of those dimensions. Again, we're dealing with mobile devices, and a good part about that is we can fall back on the familiarity of a mobile video call. Now, I don't imagine that people would want to use a spatial AR call for hours on end, but you could be on a mobile, just a standard video call, talking to somebody, but for a moment you want to show them a new piece of furniture in your house. You switch to the spatial call, you move there, you show it to them, you have this small 5-minute discussion, and then you switch back to a normal mobile video call. Again, because we're using mobile devices, this could potentially scale up to many more people at a time. You don't need everyone to own an AR headset of their by themselves. Here, what you see there is a conference call of sorts with Torin, Kritik, and Sweeby being in 3 different rooms, but still being able to interact with each other. Just a quick note about the 2D versus 3D representations. What you see here is this just a rectangle of their video feed, but that rectangle moves based on how they move in their space. So that's 2D plus spatial, just as how you saw 3D plus spatial in the other examples of my face within that. So that's like a very, very quick overview of DualStream's key features and the idea behind it. I actually have time, so I'm gonna go through some of the other scenarios that we built to sort of showcase what DualStream can do. Note, this is all actually working on phones outside of a lab using mobile internet connections. And in this particular example, not in this example, but I'll get it. This is a really quick. You may not like the context, and Ellen didn't. I realized that it's a bad one. But then the idea here was you could be looking at a painting in a gallery, share a 3D or a 2D snapshot of that with somebody who couldn't travel with you, and have a spatial interaction around it, pointing at the painting, talking about what you liked, what you didn't like. Many people have told me that this goes against everything that they hold dear with museums and galleries, and I totally get that, but this was just an initial thing that we could plan. Okay, but so consider this. Torin is by the Boulder Creek, and it is actually raining, and he's using this application because we only had 2 days before the deadline to shoot this video. But so he's by the creek, and he's using DualStream, and I'm somewhere else in Boulder, but he's sort of able to share his view that appears in my space like a portal of sorts into his space. And I realize this is very hard to see because we're both by the creek, we're both in greenish areas, but this is just an example of what the 2D version of this looks like, almost like a portal into another space. The 3D version of it is there's like this stone slab that he can sort of capture in 3D and share across to me as a point cloud. So again, just a quick scenario of how this works outside and actually where both of us are untethered from internet connections. So quick example of remote assistance, just to sort of hammer the point in a bit more. This is Turin when the laser cutter was still in the TVD lab. And let's say that he's trying to walk me through how to use this, even though I'm not in this space. I could be somewhere else and see this 3D representation transported into my space that I can inspect. And similarly, Turin sees me as a floating hologram in his space. Again, I realize that they're not the highest resolution. They can be a bit creepy, but then we wanted to get to a proof of concept stage where we could convey this idea of sharing self, sharing space, doing it on a mobile device. So I'm just going to quickly talk about how we built DualStream and some of the tech stuff behind it in case you're interested. So again, DualStream is an Android application built using Unity. And what we have is an Android phone with a RealSense camera on top of it that's connected via USB. So we're capturing information about the face using the RealSense. We're capturing 2D and 3D information about the environment using Google's Augmented Reality framework called ARCore. And we're essentially putting that all together in the application. The way this works is we get, again, the dual stream refers to 2 streams of information from yourself and from your surroundings. But even in those streams, you have 2 further streams of color information, the RGB video, and the depth information of how far each point on your face or in your environment is away from the camera. And so, like I mentioned earlier, the depth information is too much to stream in real time. So what we ended up doing instead was converting the information about depth into a single image where the pixel hue of the hue of the pixel, if you run it through a few functions, gives you an approximate value of the depth of that pixel, which you could then take a large volume of depth information, compress it into just one image, and then, so now you have 4 images. From each stream, 1 for color, 1 for depth. We then stitch those into a single frame. So now you have 1 image with all 4 sub-images in it, and then stream that over the network using a standard video call framework that is optimized for the network and for working with video. And then figure out how to extract all of this information and put it all together on the other end. That makes it look, in a way that makes it look like you're actually interacting with 3D information. So there's a lot more. So we're using things like Agora, which is a framework for video communication, audio-video communication, I should say. And we're using Photon Fusion for movement and for interactions. Photon is a multiplayer game library. And so we use things that weren't tethered to just the lab setup for a reason I'll get into. But then, again, looking at all of this, so like there's stuff that's happening with capture and compression, streaming and rendering. And then, again, it goes back to the initial 4 challenges with spatial communication that we're trying to address with DualStream. And the reason why we're using things like cloud networking services was because we really wanted to test out the application outside of a lab context. So this is from the presentation that I gave about the paper, where we just had a very, very quick formative evaluation. 5 participants in Atlas between this room and the Atlas lab, and 5 friends of mine who are located in different continents. I sent the application file to them, they installed it, and we ran a session where I showed, again, across both the in-lab and the outside lab sessions, I sort of demonstrated the features of DualStream, shared elements from the Acme lab with them in a different space, and then asked them to share information from their space with me, so just to get a sense of how the application worked. And I'm not going to go too much into the findings of the study. Again, this is just a very formative evaluation. A big part of why we did this was to just show that it even worked outside of the lab and prove to ourselves that there was some value in it. 2 interesting insights that I thought I'd bring up over here was that while we assumed that people would just by default like 3D representations over moving 2D video feeds, that really wasn't the case. Part of that is obviously because the resolution of the 3D representation wasn't that great. But I think there's something to be said about the familiarity of a video call, and combining that with spatial information, spatial movement, seemed to be enough to get a sense of interaction. And that moving to a hologram or a 3D point cloud was maybe a step beyond that. So something to think about with regards to how do you introduce this technology to people. And again, like we assume that people would want to, or people would like to share environmental information in real time. We also had the ability to sort of save snapshots of the space, which I realize I haven't spoken about much in the example so far. But it seemed like people preferred to, instead of sort of always sharing the feed in front of them, sort of walk up to this table, take a snapshot of this table, and stop sharing. And now the snapshot persists both in your space and in their space. And so you can sort of create anchors for discussion that also free you from, I guess, the load of constantly monitoring what you're looking at and explaining that to people. So just some initial finding. Obviously, there's, with this specific application, a lot more to be done that we're actually working on at the moment. Improving the resolution is a key challenge, and working with more modern devices. So this is a Samsung Galaxy S9 from about 5 years ago, and the application still runs on 30 frames per second. So there's a lot more that we see might be possible with newer phones with better cameras. Again, like you would have noticed that it was a very, very bare bones UI. Like, honestly, I don't imagine anyone would be able to use it if I didn't explain it to them. So improving that, making the interactions more useful and usable. And then I think a big question that we still have, that we're still dealing with is, sure, this seems to be a cool idea, but what are the contexts and scenarios where you actually would need something like this? And how does this fit into the broader timeline of a remote communication experience? Just wanted to bring up 2 examples of ongoing work by other people that looks at improving resolution. So there's a lot of work in getting really, really high quality self-representations and representations of the environment. So the tech is out there. It's really about finding ways to bring that into our framework and our ecosystem. But again, like so we're getting close to a time where you can actually be there. So that's an entirely computer-generated reconstruction of a park with a bike by a bench. And just imagine if you could like put that into a VR headset and you're actually there in that space. And then some of you might have seen the extremely creepy video of Mark Zuckerberg talking to a bunch of people in VR. I may or may not subscribe to that, but it gives you a sense of what is potentially possible where you have these realistic representations that you can interact with in VR. So again, this ties back to the idea of being there with people that I spoke about, was the origin of a lot of remote communication research back in the late 80s, early 90s. But interestingly, and this is kind of a tangent that I think we have the time for, there seemed to be 2 schools of thought when it came to remote communication back then. One, of course, was Park and its successor looked at how do we analyze real world spatial interactions and replicate them using digital technology. The flip side of this was the idea of not just being there, but going beyond being there. So this is from a fairly important paper in the field by Holland and Stornetta, where they spoke about how if we really want to solve remote communication, we need to focus on tools that just don't replicate the real world interaction, but go beyond what you can do in the real world, to a point where even if you have the option to interact with somebody in the real world, you would still not do that, but use the tool. Again, you can question whether that's a good thing or not, but just to point out that there were these 2, there was a fork in the road in the early 90s where it was a bunch of people looking at being there and just replicating real world interactions, and then a lot of people looking at beyond being there and seeing what you could just play around with when you had computational tools to work with remote communication. So I'm going to go back to the holoportation example. I don't know why they implemented this, but it's a fun example where if you have 3D information about a different space, you could scale it up and down and interact with it differently. So what's happening here is you have a smaller scaled down version of a child interacting with the vase. This is just a demonstration, but I think if I had to think of a useful use case for something like this, it would be like, imagine you have, I don't know, some kind of a team working on assembling a car in a workshop. And you have a manager in a different space who wants to look at the overview so they can actually see the entire thing happening on their table. Okay. just one hypothetical use case for this. But this is something that you can't do in the real world. Like, as much as you try, it's just isn't possible. But a useful interaction for scaling down people that seem people have used in remote communication is this. It's called okay. So what's happening here is that you're asking somebody for help on how to assemble a CPU. But instead of them being on your phone screen or next to you as a full-size avatar, you're actually holding them in your hand effectively, and you can see them in your hand, and you put them inside the CPU, and they get to see what's in the CPU and sort of interact with it as if they were actually scaled down and helping you point at things. Again, like the GIF does do justice, but then it's like, imagine if you could have a remote expert just scale down, enter an appliance that's broken down and help you fix it. And taking this idea to the extreme is this is work from like, I think a year or 2 years ago, about the idea of asynchronous reality, where if you're always in a remote communication situation, if you're always recording depth information, what's stopping you from recording interactions that people have asynchronously? So it's like you could go back in time and find yourself in a meeting that other people had and get a sense of what was happening there, record a message for yourself that they would see later on in a meeting that they were having. And again, this only works because all depth is being recorded, all interactions are being recorded. And again, you don't really have to go this far. I don't know if I want to go this far, but the point that I wanted to make by showing all of this is that even with what we built with UStream, there seem to be interesting possibilities for going beyond just in-person interactions. One not ideal representation is this. You can look at the video, but I think me talking is probably a bit easier. So imagine for a moment that you're at home and you just ordered a new piece of furniture, say a reading chair that you want to figure out where you should arrange in your hall, and you need somebody's help with this. So you call me, I'm at my home, and you start using UStream and sharing the 3D version of the couch or the chair in a specific corner of the room. You can take a snapshot of the chair in that space that then persists in my living room. So I see the chair over there. And then you could move away along with the chair, place it somewhere else, and take another snapshot. And so what's happening is you're essentially creating copies of the same real-world object in your space multiple times in my space. So in my room, now I see the same chair in 3 or 4 different locations, and I can kind of give you a sense of what I think is the better arrangement. Whereas in your space, there really is only one chair that you're interacting. And there's a lot more that can happen over here. It's something that I'm still thinking about, and I'd love to discuss with any of you who are interested. This idea of snapshots as not just being a moment of just capturing space at that time, but also capturing time spatially. So you could have me taking a snapshot of somebody else walking around a room, giving a demonstration. But now I'm sort of taking snapshots of them in their entirety at multiple points. It's like sort of cloning them and having them be persistent in a different space across the room. So again, this was just slightly to talk about beyond being there and some ideas associated with that with UStream. But coming back to reality and then looking at what will people want to use this? Again, I think as I've hinted at before, I don't imagine that people would use a phone with an AR call to replace a 1 hour long Zoom call or a 1 hour long Colloquium talk. But I think there is something to be said about mobile AR as a bridge to connect between multiple modalities of remote communication today. And going back to this continuum of sorts that I talked about earlier in this presentation, I hope you can kind of see that, like with UStream, we're able to get the accessibility and familiarity benefits of conventional video conferencing tools, along with some of the spatial interaction benefits of remote communication tools that involve headsets. And so what if you could bring those two together? So for those of you who've used tools like Mozilla Hubs, imagine a scenario where you have a bunch of people in a hub space on their PCs, but you could also have people joining that hub space using their phone. They could be in their room, they could be out and about, like somewhere on the road. And what you see here let me use the pointer, is Kritik using dual stream in one room and me viewing the output of that dual stream call on my PC, sort of interacting with it in a virtual world just on my. So I don't need to be also using a phone. I could be using a PC and still getting some benefits of the spatial information that Kritik is sharing with me. The same thing extends to VR. Again, Kritik's in the same room using his phone with dual stream, and I'm now in a VR space, sort of seeing him move around, seeing his environment being transported into my space. And a scenario that I like to think about over here is, imagine a situation where you're in VR and you're using a 3D modeling tool like Tilt Brush to create assets for a game, for example. But you actually have somebody who's out in the real world, potentially in a forest, in a park, streaming real world assets to you that you can then base your designs on. Again, like just some initial ideas for what this cross-device interaction might yield. And then so the big idea is that with Ustream, we're working on maximizing the potential of mobile computing, but not to replace other modalities, but sort of act as a bridge between paradigms, between the idea of desktop and screen-based computing of today, and the past, and the idea of spatial computing and interaction of the near future. And so that's like the grand vision. Something that I'm working on in my research is trying to break this down a bit more and looking at the various dimensions along which mobile devices can be useful. Up until now, with dual stream, we've only focused on remote communication, but you could also use tools like this for in-person or hybrid collaboration, where in this case, for example, we're all in this room, but there are a bunch of people who are on Zoom in their own separate spaces. So how do we potentially create these spatial collaboration systems that not only include them in our conversation, but meaningfully give each of us potential benefits for using technology? Like I mentioned in the previous slide, we're looking at connecting mobile devices with desktop ecosystems and spatial head-mounted ecosystems. And then group purpose is a little more, like it takes a while to understand, but I think there's a difference between human to human interaction and human to system interaction, where it's like there are times when I want to talk to you and then just have a conversation. And there are times that I want to talk to you around an object, around a broken down car, around a 3D printed model that I just made. So, and then a flowery way of looking at it is thinking of mobile devices as being central to these petals and picking certain petals and forming projects around them. So dual stream, for example, would be mobile devices connected to desktop computing for remote human-human interaction. And by selectively picking and choosing projects and constructing them in this way, you can kind of fill out the space and truly explore what mobile devices are actually capable of. So that's sort of the end of the content. I'm going to quickly go over sort of the key takeaways that I would like you to all have from this. And again, like, so all of this is there, but then the key part here is that to be there at another place or to actually have remote communication with somebody relies on sharing information about yourselves, sharing spatial interaction, and sharing place-based information. And at the moment, to do this, there are a bunch of challenges of capture, compression, streaming, and rendering. And the way in which these are being solved has sort of created this divide between tools that are accessible, video conferencing, but not spatial, and tools that are spatial, head-mounted displays and stuff, but not widely accessible. And with dual stream, what we've tried to do is create a mobile-based remote communication experience that addresses all of the key aspects of remote communication while also solving most of the key challenges within our context. And it's not just between mobile to mobile interaction of being there and being here, but also looking at cross-reality, cross-device interactions and building out this ecosystem of remote communication where mobile devices act as the bridge between the screen and desktop computing paradigms of the past and the spatial computing paradigms of the near future. So this slide, like if you remember, nothing else, this. And all of this, like I've been talking for 47 minutes, not bad. But this really has been a much larger team effort. So the paper dual stream, that's the author list. So Kritik over here was a big part of it. Sweeby, who's I think online.
Yeah.
Torin, who I'm not sure is online, but is a big deal. Then Amy, Mark, and Ellen, who were the advisory team for this. Like I mentioned at the start of this, we've been collaborating with Ericsson Research on this project for a while. And I just wanted to mention Craig, Alvin, Vanilla, Barry, Kami, and Bear. We're like, we have meetings with them every 2 weeks, and then they provide a lot of valuable feedback. There's this back and forth that's really helpful for our research in this project. And of course, the Apple Lab at large. The number of times I've invaded that space to just shoot videos or have them do on-screen talent, feedback on papers, it's just been really helpful. So that's it for me. Thank you for listening. There's more information about the project at this link. I'm happy to answer any questions. Drink some first.
In addition to streaming your point cloud and your video, I wonder if it would be useful to capture the shape and the colors locally, so you begin to build that in, but only transmit when you need to make changes. The compression that I see focused on in most of this is the compression of the point cloud or the depth or the colors. And I think painting the model, bringing the model and painting it, and then slowly sending updates might be a better approach. And as you can do well then.
No, for sure. I think a large part of us not doing that was I couldn't figure out how to do that in the time for the project.
Oh yeah,
But because it's not just so we were already dealing with a lot happening just on this old mobile phone.
Yeah.
That building that spatial map, in addition to VR tracking, in addition to streaming and re-rendering, was a bit too much for this to handle. Which is why I was like, the moment you get a frame, send it across and have the other person deal with what the rendering consequences are. But a lot of systems today, again, like not just that, I think so the idea of, let me go back. So there's this one side where I was showing you the part with the pipe and then the bench. That's usually just somebody walking around for 10 seconds around it, and then you process that information for a few minutes, and you get a fully very high polygon, high quality model. So that is an option for the near future. This was just a limitation that we had in this, but I definitely would like to have that integrated into this.
I really like the remote support setting up the computer center, and I think we've had a friend who's not here at the moment from the police department who has some things to use the equipment that the university sets aside. And what I saw there was humans talking back and forth and seeing things together. But one thing you could add that's on the as a USB to become a mouse and a keyboard and the disk of things that need to get set up so that you could be more particularly for that use case to help someone not only put the pieces together, but get the operating system on it, configure it, and get them going. And
Not just the physical remote
and make a living as long as they got one of those phones that they can connect to people to help them with.
And definitely, like this was all just physical, but yeah, connecting to software is an entirely different aspect of this. Yeah, thank you. Yes.
Moving forward, do you plan on trying to expand it beyond just Android phones? And if so, are there any problems you anticipate?
I could talk forever. Like so the reason we use Android is because it's notoriously difficult to share applications in an iOS framework. So as much as I would like to use the iPhone and all of the nifty sensors that it has, I can only build to an iPhone that's directly connected to my Mac. And that wouldn't have worked with me wanting to send this application to somebody outside of Portugal. So I just heard yesterday from somebody who once worked at Apple that it might soon be possible to sideload applications onto iPhones. If that's the case, then that would really make it more compelling for me to develop on that. But again, I think Android was just that we had a lot of devices. I'm more familiar with Android development, and the ecosystem is much more open than the iOS side of things. But I would like, and that's something that I hope to explore this semester, which is we do have iPads and then iOS devices in our lab. So just building out some basic interactions and seeing how we can connect the two, because again, there technically are systems where you code something on a PC and it creates something that just works as is on an Android and as is on an iOS. But there is some involvement in that process. So figuring that out is something that we're doing right now. But yes, I would like to use iOS devices. They just make it incredibly hard for me to do.
Did you look at a test one? So, because I know that's a way in which you can put
So there,
apps onto an iPhone. that's
There-
someone else's.
yes, but there are these like tiny sort of barriers to this, like psychological barriers. The fact that
Okay.
I need to pay $100 a year to be a developer for iOS,
Yeah.
but I can just send an APK to anybody and have them run on Android phone.
Don't you also need approval for test flight from Apple?
No, I don't think so.
Oh. I think within a certain closed set of devices, you can send it across. There's multiple layers to this, but it's hard.
Yeah. I
They
just know
do
that
not
friends
want
done
you
it to
to
me,
do
they make
Yeah.
a little thing and they, you don't put it on the app, so we put it through test flight, you know, and just occurred, you know, that was maybe an option.
Yeah, Casey.
I have a couple questions actually, but I don't want to dominate time. I think my main one is like, reference beyond cleanness. And I'm curious, like, is that just a frontier that you're pointing out? What role do you envision this system as having in the beyond cleanness?
So that came in later in the presentation because Stream was very much a being there application. It was like, we need to replicate some of this to make remote communication better. And it was the beyond being there idea kind of came along later in the process where we had interactions that seemed to be able to do more. But I think for me, as like just this is personal bias at this point. What I'm most interested in terms of going beyond real person interactions is looking at the element of time and then memory and looking at, again, like right now we're recording the Zoom call. I wonder if anyone will really watch it, but if you were using a spatial communication tool to have interaction, and if you were able to record that and allow other people to access that at different points of time, to sort of engage with the same discussion, even though they weren't there at the same time, not even at the same place, is something that I think these tools are, at least for me, most compelling for. I'm not like, sure, the idea of scaling somebody down and putting them inside the CPU is great, but for my own personal research, I think that something I'm interested in is exploring the time dimension and how we can go beyond synchronous interactions using these tools.
Thank you. My only other question I wanted to ask is like, AI is popping off. Do you see a world where AI is part of solving these problems?
Solving this problem. So
Like, for instance, like you have like the point cloud problem, or the compression problem. Like, do you see room for AI in your system?
I think there's definitely room, and whether I like it or not, it's being shoved into systems like this by a bunch of other people. So Meta has codec avatars, the really high fidelity versions of things, are very much using machine learning, and even the 3D reconstruction stuff is using machine learning and AI to get it done. I think there's a trade-off, and it depends on context. So there are times when you might want the pristine high fidelity version of an environment of a person to interact with. A business meeting, for example, or an interview. But there are times when I just want to talk to my brother. I don't want to see him as an avatar. I'm okay with seeing a low resolution point cloud of him because I can probably fill in the gaps. This is somebody I've grown up with for all of my life. So again, this choice between real and mediated or artificial would probably have to happen based on the context. I think I'm inevitably going to have to integrate some of it into my system, but I personally will always leave an off switch where, like, if you are okay with just a low res point cloud, go for it, because that is real information. That's like, if I've fallen down and I have a bruise on my head, that gets communicated with the point cloud. That wouldn't come across with the AI version of my face. So
Do you see, okay, you spoke a bit about the limitations of AI headsets for this, and you could really focus on mobile. Do you see this as like the solution for now using mobiles and like the near future, but AI headsets will kind of overtake this? Or do you see it as like, no, actually probably mobile devices would be like more dominant and AI headsets are a bit more kind of niche use cases? It might come into your ecosystem, but actually will be more likely to use like mobile handsets rather than headsets.
I don't think everyone's gonna have an AR headset. I really hope everyone doesn't have an AR headset. But I think that there are certain contexts where you cannot use an AR headset. Like, so there are people, like, again, a big challenge with AR and VR has been motion sickness. And I am lucky that I don't get it when I wear the headset, but then there are people who do. And it's a lot. Like, you cannot look at things for more than a few seconds before feeling nauseous. That's when this helps. This has severe disadvantages. This is not stereoscopic. This doesn't give you a 3D view of things. There might be ways to change that as opposed to force people to wear headsets. But I think, again, like I got towards the end of this, I think it's a lot more about building an ecosystem of connecting desktop, mobile, AR headsets. And even if we are going into a world where everyone has an AR headset, I would say going via a mobile device is probably a more accommodating way of getting them to that point than just putting the glass on them now and expecting them to understand how to interact spatially with it. So it's like this bridge between going from computers to spatial computers that might be. I personally think the phone will always have a place. It's personal and it's proliferated around the world in a way that headsets will take decades to do. So it's not just now, it's for the near future as well. Yes.
It's like a really weird thing, but what if you could have like, do you know those drones that follow you when you like ski or something and it's pretty close to you? And I wonder if you could incorporate that in like a idealistic world where there's a little drone that's kind of hovering that can project and record you so you can use your hands to like move objects around in your physical space.
Sure. So there's actually, people haven't figured out drones yet, but they have figured out work where it's like the phone with its mobile AR display is mounted on like a moving robot. So instead of you holding it, like it's walking around with you.
Yeah.
I don't know, 10 years from now, maybe you like press a button and a fan pops out and then this floats around. That's really cool. I don't know how to prototype it myself, but I think that would be an interesting way of working with it because the hands-free interaction is one of the main benefits that people ascribe to headsets. And if that was possible here, there's a lot more that we could do. So something I have thought about, I just don't know how to implement it.
Yeah.